log ने वो यूज़ किया है okay so calorimetry is a branch of physics wherein we measure heat. Okay, calorimetry is a branch of physics where we measure heat. Okay, so there is a specific device which is called a calorimeter. Device that is called calorimeter. Experiment is to be done inside the calorimeter, right? And whatever you are doing, that is calorimetry. If you are trying to measure heat related to some substance. Okay. Now, let's read example 11.3. A sphere of aluminium of 0.047 kg placed for a sufficient time in a vessel containing boiling water. So what are we doing? We take an aluminium sphere and we put it inside boiling water, and we do it for a long time. That is, we put it inside for a long time. So when you do that, what will be the temperature of that sphere? It will become 100 degrees. Clear or not clear? Sure? Yes, no. Because boiling water will have temperature 100. In the sphere, 100. So here is that aluminium sphere. Temperature will be 100 degrees. Mass is given. It is then immediately transferred to a 0.14 kg copper calorimeter. So from boiling water it is picked up, obviously not by hand but using a pair of tongs. Okay. It is then immediately transferred to a copper calorimeter. So this is a copper vessel. A copper calorimeter means the vessel is made up of copper. Containing, okay, its mass is given. How much mass of copper? 0.14. And containing 0.25 kg of water. So inside this copper container, how much water is there? 0.25 kg. Clear so far? And at what temperature? At 20 degrees. So what that means is, this water and this copper, all of it is going to be at 20 degrees Celsius. Why so? Because this is the inner wall of the calorimeter or inner wall of this vessel will be in contact with water. Okay, and generally a calorimeter, a good calorimeter is insulated on the outside. You understand what is the meaning of insulated? Insulated means heat cannot go out. And I will to know. This is just for drawing. Okay, it is insulated so that heat will not go out. So we will take this and we put it inside, of course after opening a lid, right? Okay, and then there are small holes here through which a thermometer is inserted and we can measure temperature. Understood? Okay, figure I don't see. So there is a small hole through which thermometer is dipped inside, so we can measure the temperature. Okay, let's read. The temperature of water rises and attains a steady state at 23 degrees Celsius. So what's the final temperature of water? 23 degrees Celsius. Okay, why did the temperature increase? Why did it increase? This was hot. You put it inside. So what will happen? The hot body, that is the sphere, will lose heat. It will give heat to water. So water's temperature will increase. At the same time, the sphere's temperature will decrease. Final temperature means at steady state, means after everything is over. Finally, temperature becomes 23 degrees Celsius. Okay. One thing to know. This 23 degrees Celsius will be the final temperature of what? Of sphere, of water, or of copper? Of all. It will be the final temperature of all. But they are the same thing. The final temperature of each of the material will be same. Why am I saying that? Listen to this step. Suppose it is not. Let's say that this is final temperature of water. But suppose temperature of sphere is still 50 degrees. Suppose. What will happen? Then heat will flow from sphere, that is water body to water, which is the cooler one. Yes or no? So would you call this final? But change now still the temperature is going to change. So when do you get equilibrium? Recall equilibrium from chemistry. Thermal equilibrium. What is it called? Thermal equilibrium. Thermal equilibrium means two bodies will have same temperature. Only then the flow of heat will stop and temperature will become constant. Understood? Yes or no? So final temperature 23 degrees Celsius is for which object? For sphere, for water, and also for copper. Absolutely clear this? Sure? Okay. So keep that in mind, and now we can solve the question. What I tell everyone is that calorimeter related question like this. They're just like writing an account. Okay, from where it flows to what? That is what absorbs heat and what releases heat. Okay, it's just like that. Let's see. Two parties. One is giving party and one is taking party. Okay, so sphere is the giving party. Correct or not? Sphere will release heat and water and copper will absorb. So what's going on? Sphere's initial temperature was 100 degrees. From 100, the temperature changes to 23 degrees Celsius. Clear? On the other hand, when this happens, what happens to water and copper? Its temperature will change from 20 degrees Celsius to 23 degrees. That's it. Everything same now. Is it equilibrium? Yes. Okay, now we will solve question. Okay, now we will solve when we put calculate. Right? So you can do it in two ways. Listen to this carefully. You can do it in two ways. One is by thinking that the whole system, that is the whole calorimeter, is isolated. What is the meaning of isolated? You have studied this in chemistry. Isolated would mean that heat will not be able to go out or in. Insulation purpose isolation. Right? So for the whole system, Q is 0. For the whole system, Q is 0. Why Q is 0? By the whole system, from outside heat is not absorbed and nor released. Neither absorbed nor released. Clear? Because it's insulated. So we can write that Q for sphere or aluminium, if you write aluminium, plus Q for water plus Q for copper should be equal to 0. Did you understand this line? The addition of Q for all the three substances should be equal to 0. Now, let's put value. What's happening to the aluminium sphere? Its temperature is changing. Do you remember that heat can do two things? One, it can change temperature. Second, it can change phase or state. Here to the sphere, what is the heat doing? Only change of temperature. So what's the formula when temperature is changing? Q at a delta T resolution. Q equal to either ms delta T or Q equal to capital S delta T. But generally we use ms delta T. So we are going to use Q equal to ms delta T. So mass of aluminium, S of aluminium and into delta T. Okay. Is it clear what we are doing? Yes or no? Q equal to ms delta T. So aluminium and delta T. Delta T of aluminium here. How much? What should I write? 23 minus 100. What is the meaning of delta? Final minus initial. So what's final? 23. Initial 100. Got it? I will go on to this. Next, you tell me. Come on. MW SW into delta T. What's delta T? 23 minus 20. Again, there is no need to convert to Kelvin. Difference the same way. plus Q for copper. Come on. M C S C delta T. What is delta T? 23 minus 20, and that is equal to 0. And I just want to confirm that you have really understood why we get Q equal to 0, because the whole system is isolated. Ideal case. You know, there will be little bit of heat leakage. I'm sure you understand. You know those thermos flasks, even they cannot hold the heat 100%, correct or not? So there is no device ever made which can be completely insulated or isolated. Clear? You can never isolate it. It's an ideal concept. But still, in a short time, there is not much loss, so we can still do it. So total heat change 0, and then we put all this. Just put the values and calculate. Okay, let's start. Mass of aluminium. Find the current. Each find current. We want to find specific heat of aluminium. Okay, so mass of aluminium sphere. What was it? 0.0477. Okay, SAL to be found. This is going to be minus 77. Okay. Plus mass of water. How much is mass of water? 0.25 kg. Remember. Okay. SW. So 4.186 into 10 raised to 3. Okay. Again, if you remember, I asked you to memorize this value. It is 4.186 joule per gram per Kelvin. So if you write it in per kilogram, you have to write it to 10 raised to 3. Right? 1 gram is 4.186. So for a kilogram, it is 4.186 into 10 raised to 3. Okay. That's done. Now this is 3. Here, what's mass of copper? 0.14. What's S of copper? Specific heat of copper, not given in question or given? Not given. Look at it from the table. 6.4. Huh? Where is it? Yeah, got it. 386.4. Okay, yeah, it is in standard units only, SI units, so no problem. 386.4. Okay, into 3 is equal to 0. Come on, you have to do the calculation. Please hurry up. I'm giving you a minute. Do it, right? Again, making a chart like this really helps you see what you are doing, so that you don't lose out on any term. कल तो ले लो example there. Done? Hopefully the answer isn't wrong in the book. Right. Value आपकी साथी है ना अब मैं आपसे 0.911 is that specific value here? Okay, let's do this equal to okay, have a look here. So first of all 77 into 0.047 a gram of the kg confirm that kg એનાથી કઈ ફરક ન પડે ખાલી પોઈન્ટ આપજે 3.619 SEL plus here 3.41 4.186 okay so this is 3.1395 into 10 raised to 3 plus 1.758 0.14 into 386.4 into 3 yeah 162.29 equal to 0. I believe you would have made a mistake here in that. Right? So SHL equal to this plus this and then divided by this. Okay? So and then this is 3139.5. So this plus 3139.5. 3301. 3301.79 divided by 3.619. So 912.3. Okay, and this is in joule or kg Kelvin. Okay, right? So you have to be careful with calculations. Right? So this is the specific heat of aluminium. We are getting a slightly different answer. It is okay. Now let's solve more questions. Yes. Example 11.4. Okay. Example 11.4. It is also related to calorimetry or stages of heat and all that. Again, making a chart very important. Okay, whatever changes are going on, if you will make a list, you can make a chart, it will be easy for you to visualize. So here is example 11.4. When 0.15 kg of ice of 0 degree Celsius. So there is ice and it is at 0 degree Celsius, which is mixed with 0.3 kg water. Okay, so we have 0.15 kg ice. It is mixed with water. How much water? 0.3 kg. And at what temperature? 50 degrees. In a container. So really what they mean is in an insulated container, right? So that heat will not go out or in. The resulting temperature, so the final temperature when you mix both of these, what's the final temperature? What's the final temperature? Did you read it? 6.7 degrees Celsius. Okay. Calculate. So using this information, we have to calculate heat of fusion of ice. Heat of fusion is latent heat, specific latent heat of fusion. Yes, LF. That is, we have to find what is LF. Okay. So let's start. Make a chart. Okay. Ice ki chalu like that. On one side you have ice. And on one side you have water. Okay, so which is cooling down and which is heating up? Ice is cooling down. No. ice will get hot compared to what it was earlier. 0 mati 6.7. Water will become cold, that is, it is cooling down, that is 50 degree to 6.30. Clear? Okay. So let's write it here. One side absorbing heat, the other side releasing heat. Okay, so one side absorbing heat. First there was ice. At what temperature? 0 degrees Celsius. Look at the steps. Does ice directly become water? This is of course water. At 6.7 degrees Celsius you cannot have ice. Temperature will not change beyond 0 until all the ice melt. Got it? So at 6.7 degrees Celsius it's definitely water. So pehla ice mati water convert થાય. Did you understand that? Yes or no? Melting process happens. Once all the ice melts, the water temperature will start increasing from 0 to what? 6.7. Did you understand this chart? Or not clear? Directly no that. There are two steps. First, ice at 0 degrees Celsius will become hot. It will get converted into water. Then only water's temperature will rise. Now let's go to the other side. Okay, this is the party that is absorbing heat, and the other party which is releasing heat. So there was water to start with. At what temperature? 50 degrees. From that water, what happens? See to 6.7 and then. Do you understand what I am writing here? Yes or no? This water doesn't need to do anything else, right? Its temperature will decrease from 50 to 6.7 as it will release heat. After the heat and after that, so it will do all this. Got it? So that's it. Now once again, if we assume that we are doing all this in an isolated container, then Q is equal to 0. So total Q in all the steps, big party na de पण Q आता है बता 0. In every step you have a Q. You understand what I said? In every step you have Q. So ice to water 0 0. What is this process called? Anjo, what is this process called? Ice to water 0 0. Water is. What is this process called? Melting. बराबर ने? Ice water convert from ice to water. What is this process? समझ पड़ी है? समझ पड़ी. So for melting, is temperature changing or state changing? State. Okay. So for state change, you should write Q equal to ml. Yes or no? Yes or no? Heat can do two things. What? Change temperature or change state. So here state is changing and the ml. So first one here. Right? Let's label this number 1, let's label this number 2, let's label this number 3. 1, 2, 3. And Q1 my ml out. Did you understand or not clear? Our first process. Do you visualize processes? Third process, which one? Ice melts to water. Process 1. Then water heats up to 6.7. Process 2. On the other side, this water cools down to 6.7. Process number 3. Not what is that? Bouncer there. Q2. What? Change of temperature or not? Change of temperature. And third one, so एमा बे मात्रे formula होते हैं. कोई formula होते हैं. So for Q2 and Q3 both, you are going to use ms delta T. Plan समझेंगे. Okay, step wise. આ બધું analysis એક જ વાર કરવું પડે. બીજી વખત સમ કરશો તો જાતે જ થશે. It would be easy for you. Right, so Q equal to 0, let's begin. So Q1 plus Q2 plus Q3 equal to 0. Why Q1 plus Q2 plus Q3 is equal to 0? Both isolated system. So that when you add all the heat changes or heat, you get total 0. So Q1. What should I write for Q1? ml. this is ice, mass of ice. Did you understand that? Melt point that ice size plus Q2. Now here, this water, okay, this water. So I should be writing MSW delta T. Delta T, that is what? For process to have to what? 6.7 minus 0. One more thing. Which mass should I be writing over there? Water ki ice? Ice, because this ice melted and makes this water, so mass will remain same. So here we should be writing mass of ice. If about tension માં ન જવો હોય તો સીધી વેલ્યુ મૂકી દેવાની એકદમ, નો પ્રોબ્લેમ. ઓકે, હું કોણે કીધું કે હવે એક્સપ્રેશન લખવું જ પડે, બરાબર? Here we should write LF for what? Latent heat of fusion or melt. Yeah, Q3 now. Come on. What should I write for Q3? You tell me. MW. Because water given to us is 0.3 K. Then SW. And then SW. And then delta T. What is delta T? 6.7 minus 50 equal to 0. Final minus initial delta T. Okay, that's what this means. Let's put values now. And beginning MI. What's the mass of ice? 0.1. Okay. LF plus 0.15. Specific of water. अब तो याद रखिए 4.186 into 10 raised to 3 kg joule per kg per Kelvin into 6.7 plus mass of water how much? 0.3 into SW again 4.186 into 10 raised to 3 and into 6.7 minus 50 is minus 43.3 equals to 0. So that's all. Find out LF. Would anyone like me to repeat what we did here and how we got Q1, Q2, Q3? Looks like you are done. Unit like 2 away. Joule per kg. આવી જાય ને આન્સર કરી દો. Okay, next example. Start reading it, make a chart. We will now solve the next example, that is 11.5. So I want all of you to make a similar chart like we did earlier. Here it's straightforward question. It says calculate heat required. I'm a base side change. First read the question and then try to make it up. Calculate heat required. So we have to find Q. To convert 3 kg of ice at what temperature? Minus 12 degrees Celsius. So that's where we are starting. Kept in a calorimeter to steam. So from ice we have to make it steam. Okay, at what temperature? At 100 degrees Celsius at atmospheric pressure. Okay, and then given specific heat of this and this and this and this. Okay, so where are we starting? What's the initial substance? Ice. And at what temperature? Minus 12 degrees Celsius. So then the flow chart banao. From ice minus 12 degrees Celsius, what do you get next? From ice, which is at minus 12 degrees Celsius, what do you get next if you heat it? See the water is there? First of all, you heat it. So what will change? Temperature or state? Temperature change. What will it become? 0 degrees Celsius. So that will be your next point. Okay. So what will you get? Ice at minus 12. Ice at 0. Okay. Pause. Then once again, let's say you heat further. What will happen now? Ice will change to water. At what temperature? 0 degrees Celsius. 3 second step. Okay. Ice will change to water at 0 degrees Celsius. Base step again. Now third step, you heat it further. What will happen now? Water at 0 will go to water at 100. Barabar ne? See the steep thing. Barabar. First temperature will change. Only one of the two may change at one time. Either temperature will change or state will change. Water at 0 to water at 100. How is it there? Steam at 100. Water at 100 will now become steam at 100. But a phase change. Okay, is final temperature 100 or something else? 100. Okay, kitla steps aayega? 4 arrows, that is 4 steps. So total heat required Q will be equal to total heat required Q will be equal to Q1 plus Q2 plus Q3 plus Q4. That is the find karo. All values are given. Come on. Wherever required, put correct value of LF, LB, S of ice. Specific heat of ice is different. List specific heat of ice is not same as specific heat of water. If some value is not given, then we can look at it from the table. These are the steps. Ice at 12, ice at 0. Then water at 0, and then water at 100, and then steam at 100. 1, 2, 3, 4. So it's Q1, Q2, Q3, Q4. Done.